Hello everyone, welcome back to my channel. Today we are going to see about the relationship between central and non-central movement. So first we will denote and write the formula of central movement and the non-central movement. Therefore central movement is denoted as mu r, which is equals to 1 by n summation I is equals to 1 tends to n fi into xi minus x bar whole to the power of r. The moment taken about the mean is called the central moment. And here xi minus x bar is equals to zi. Remember these formulas. So it is needed for further calculations. And non-central moment is denoted as mu r dash is equals to 1 by n summation I is equals to 1 times to n fi into xi minus a whole to the power of r, and xi minus a is equals to di. Here the moment taken about any arbitrary point such as a is called the non-central moment. So if r is equals to 1 and r is equals to 2, 3 and 4, the non-central moment becomes in this way. So now we will write the relationship. Therefore mu r is equals to 1 by n summation I is equals to 1 times to n fi into xi minus x bar whole to the power of r. Consider it has the equation 1. దీన్ని equation 1 గా అనుకోండి. ఇప్పుడు మనం సబ్ట్రాక్ట్ చేయాలి. ఏని సబ్ట్రాక్ట్ చేయాలి, యాడ్ చేయాలి. Subtract the arbitrary point a to the equation 1. Therefore mu r is equals to 1 by n summation I is equals to 1 tends to n fi into xi minus x bar plus a and minus a. So see here, I am writing this xi minus this minus a here and minus x bar plus a whole to the power of r. We know that xi minus a is di. So I substitute 1 by n summation I is equals to 1 times to n fi into di minus x bar plus a whole to the power of r. So you know the formula, right? Mu r dash is equals to 1 by n summation I is equals to 1 times to n. From this we will extract minus x bar plus a. Mu r dash is equals to 1 by n summation I is equals to 1 times to n fi into xi minus a whole to the power of r. Let me consider r is equals to 1. Therefore mu 1 dash is equals to this formula we will get, the first one. 1 by n summation I is equals to 1 times to n fi into xi minus a whole to the power of 1. So we will multiply this 1 by n summation fi to xi and minus a. 1 by n summation I is equals to 1 times to n fi into xi. Therefore a is constant, we will keep it in a side way. Therefore minus a and 1 by n summation I is equals to 1 times to n fi. I know that you have seen this formula, no? In the mean, in the descriptive statistics, we have learnt the mean formulas. This is the mean formula of discrete series. Summation fi xi by n is the mean formula for discrete series. So we get the x bar. X bar is equals to summation fi xi divided by n and minus a 1 by n, and we also know that summation fi is equals to n. Therefore n, so we can easily cancel this n and this n. Therefore mu 1 dash is equals to x bar minus a. Here we have minus x bar plus a. So multiply with subtraction. Minus mu1 dash is equals to minus into x bar is minus x bar and minus into minus plus a. Therefore minus x bar plus a is minus mu1 dash. Substitute this mu1 dash in this. So you get mu r is equals to 1 by n summation I is equals to 1 tends to n fi into di minus x bar plus a is minus mu1 dash. Therefore minus mu1 dash whole to the power of r. Let us consider the r is equals to 0. Therefore the mu r becomes mu 0 is equals to 1 by n summation I is equals to 1 tends to n fi into di minus mu1 dash whole to the power of 0. Anything to the power of 0 is 1. So fi into 1 which is equals to 1 by n into summation I is equals to 1 tends to n fi. Therefore mu 0 is equals to 1 by n summation I is equals to 1 tends to n fi, and we know summation fi is n. Therefore mu 0 is equals to 1 by n into n. Cancel this n and we get a mu 0 is equals to 1. So now we will assume r value is equals to 1. Therefore if r is equals to 1, then mu1 is equals to 1 by n summation I is equals to 1 tends to n fi into di minus mu1 dash whole to the power of 1. 1 to the power of 1 is 1 only. So di minus mu1 dash whole to the power of 1 is equals to di minus mu1 dash only. So mu1 is equals to 1 by n summation I is equals to 1 tends to n fi into di minus mu1 dash. So multiply this 1 by n summation I is equals to 1 tends to n fi to di minus mu1 dash. So we get 1 by n summation I is equals to 1 tends to n fi di, and here the mu1 dash is constant. So we write it outside, and 1 by n summation I is equals to 1 tends to n fi. Therefore we know 1 by n summation I is equals to 1 tends to n fi di. Here di is nothing but xi minus a. So I am writing here, see carefully. Therefore 1 by n summation I is equals to 1 tends to n fi into xi minus a. If we keep to the power of 1 or also we not keep also, the answer will be same. Anything to the power of 1 is 1 to the power of 1 is 1. Therefore minus mu1 dash, and summation fi is n. So we get capital N, and capital N and cancel, and we get mu1 dash. So once you see the formula here, the mu1 dash is 1 by n summation I is equals to 1 tends to n fi into xi minus a whole to the power of 1. So here is also the same. So we can easily write it as mu1 dash minus mu1 dash. Therefore what? Mu1 dash minus mu1 dash, which is equals to 0. So we got mu1 is equals to 0, which is the first central movement, and it is also called as mean. So now we will see about the variance mu2, which is nothing but this central movement of the second, or the second central movement. Now let us consider r is equals to 2. So the mu2 becomes 1 by n summation I is equals to 1 tends to n fi into xi minus mu 1 dash whole to the power of 2. If you had remember the formula, it can be easy. If you don't know the formula, I am saying here. Therefore, we have a formula for x minus y whole to the power of n, which is nc x minus 1 whole to the power of n is equals to nc0 into x to the power of n and y to the power of 0 minus nc1 x to the power of n minus 1 into y to the power of 1 plus nc2 into x to the power of n minus 2 and y to the power of 2 minus nc3 x to the power of n minus 3 y to the power of 3. In this way it will go on. So here is also in the same way, xi minus mu 1 dash whole to the power of square, which is in the form of x minus y whole to the power of n. So now we can easily write in this way. Therefore mu 2 is equals to 1 by n summation I is equals to 1 tends to n fi into nc0. Here the n is 2. Therefore 2c0 into x to the power of n, which is xi to the power of n is nothing but 2 and y to the power of 0. Therefore mu 1 dash to the power of 0 and minus 2c1 into xi to the power of 2 minus 1 and mu 1 dash to the power of 1 plus 2c2 xi to the power of 2 minus 2 mu 1 dash to the power of square. Here nc3, which is nothing but 2c3. Here the n cannot be greater than the r value. So here here the n should not be less than the r value. So 3 is less than 2. So we will stop up to here only. Therefore mu 2 is equals to 1 by n summation I is equals to 1 tends to n fi. Do you remember the permutations and combinations? Here 2c0, which is nothing but the combination. NCR formula is equals to n factorial by n minus r factorial into r factorial. So 2c0, which is nothing but 2 factorial by 2 minus 0 factorial into 0 factorial. 2 minus 0 factorial is 2 factorial. Therefore 2 factorial cancel and 0 factorial is 1. So we get the 1. 2c0 is 1. 1 into xi square and the formula is di, right? Here. See the formula. First, the mu r is di minus mu 1 dash whole to the power of r. So here we have written xi. So we need to change it. Therefore, which is di, not xi. Di and di. Therefore, di square. Anything to the power of 0 is 1. So 1 and minus 2c1, which is 2 factorial by 2 minus 1 factorial into 1 factorial. So which is nothing but the 2. Therefore minus 2 and 2 minus 1 is 1. So di to the power of 1 and 1 into 1, which is equals to 1. So mu 1 dash whole to the power of 1 is also mu 1 dash. plus 2c2. Therefore, 2c2 is equals to 2 factorial by 2 minus 2 factorial 0 and 2 factorial. So we get 1. Therefore, 1 into 2 minus 2 is 0. And anything to the power of 0 is 1. So di to the power of 0 is 1. Therefore, 1 and mu 1 dash square. Therefore, mu 2 is equals to 1 by, multiply this 1 by n summation I is equals to n fi with this all the values. Therefore, 1 by n summation I is equals to 1 tends to n fi into di square. 1 into 1 is 1 and 1 into di square is di square. And here we have minus. And here 2 and mu 1 dash is constant. So we write it in the outside. Minus 2 mu 1 dash 1 by n summation I is equals to 1 tends to n fi into di. And here plus symbol, and 1 into 1 is 1. Mu 1 dash square is constant, so we write it outside. Mu 1 dash square into 1 by n summation I is equals to 1 tends to n fi. So see here carefully. We know that di is equals to xi minus a. Therefore, summation I is equals to 1 tends to n fi into xi minus a whole square. And if power is not there means, which is nothing but the 1. And 1 to the power of 1 is 1. Therefore, di to the power of 1 is also di. So we can write di to the power of 1. Therefore, minus 2 mu 1 dash and 1 by n summation I is equals to 1 tends to n fi, and the di is xi minus a whole to the power of 1 plus mu 1 dash square. Here summation fi, which is equals to n, capital N, and we can easily cancel capital N and capital N. We remain with only mu 1 dash square. So I have not written here this calculation, just I have written this mu 1 dash square. Therefore, if you seen in the formula, if you see this one and this one, this formula, this formula, which is same, so we can write mu 2 dash. Therefore, mu 2 dash minus 2 mu 1 dash here also. Therefore, 1 by n summation I is equals to 1 tends to n fi into xi minus a whole power square becomes the mu 2 dash. Here whole to the power of n, whole to the power of 1. So it will becomes mu 1 dash plus mu 1 dash square, the remaining one. So mu 2 is equals to mu 2 dash minus 2 mu 1 dash square plus mu 1 dash square. If we subtract, then we get mu 2 is equals to mu 2 dash minus mu 1 dash square, which is the second central moment and also called as variance. So in this today's video, we have learnt about the central moment and non-central moment, and what are the first central moment, which is also called as mean. Mu 1 is equals to 0, and the variance mu 2 is equals to mu 2 dash minus mu 1 dash square. I hope you have understood this video. Please like, share comment, and subscribe to my channel. Stay tuned and